Laser Focus World is pleased again to partner with CLEO this year to support the Innovation Award Program. The program was established to honor exhibitors who have demonstrated outstanding leadership and made significant contributions in advancing the field of optics and photonics. The grand prize winner of the 2012 CLEO Laser Focus World Innovation Award is BioPhotonic Solutions, Incorporated, which is being honored for the development of the femtoAdaptiv, the first ultrafast laser capable of adaptive pulse self-compression that delivers ultrashort at sub-10 femtosecond pulses at the focal plane of a microscope objective. Please welcome Marcos Dantas, President and CEO, who will accept the award.
Hello, I'm Gail Overton with Laser Focus World magazine, and this year we are honoring the winner of the CLEO Laser Focus World Innovation Awards. The winner this year is BioPhotonic Solutions, and I'm with Marcos Dantas. He is founder, president, and CEO of BioPhotonic Solutions, and their product very deservedly won this award for its many excellent features. The product is called femtoAdaptiv, and it basically is an automated ultrafast laser. And Marcos is going to explain what makes this product so innovative in the optics industry today.
Well, we are very excited to introduce this femtoAdaptiv. Until today, when people want to use femtosecond lasers, they need to have usually an expert that is going to make adjustments or adapt the laser to the experiment. This, for the first time, is a laser that adapts to your experiment. So it doesn't matter what kind of optics, or if someone is using for microscopy, they may want to use different magnification objectives. And so this laser, what it can do is it can sense dispersion, including high-order dispersion, and correct it automatically without any moving parts. This is what's exciting. So basically, with a push of a button, you know what is the pulse duration, and the femtoAdaptiv gives you full control over the pulse characteristics. You can have the shortest pulse, or you can have 2 pulses or 3 pulses. You can decide at what time each of the pulses arrives, and also gives you full control over the spectrum. So you can tune it. You can tune the spectrum from 650 to 950 nanometers with any pulse duration, for example, 20 femtosecond tunable across the bandwidth, or you can decide to use, for example, 2 frequencies and do what's known as coherent anti-Stokes Raman scattering, or so on. So it really is a very flexible tool that adapts to your experiment, and the people doing research with it don't need to spend the time to tweak the laser and optimize it, and it also, you don't need additional equipment to measure the pulses, for example. So we're very excited, and we think that this femtoAdaptiv is giving us an idea of the future of femtosecond lasers, where you no longer need to adjust static optics.
So Marcos, maybe you can show us how the device actually works, maybe in a graphical form for our audience.
Yes, sure. What the femtoAdaptiv does is it gives you full control over the frequency or time characteristics of the pulse. So, for example, we can make an interferometric autocorrelation, such as the one on the screen right here. And this one in particular was obtained with 125 attosecond steps, but the system can give you attosecond resolution. And then from these measurements, you can confirm the pulse compression. And what's special is that this can be done after complicated optics, for example, a microscope objective. And so at the focal plane, you have a direct measurement of the pulses. And so this laser is very good for microscopy, but it also can be used to seed OPCPA systems, and can be, there is a version that is CEP stabilized that is important for attosecond research.
So Marcos, if you had to talk about one overwhelming benefit of this instrument for your customers, what would that be?
Well, the most important thing is that this laser, when used for nonlinear optical microscopy, it really gives you the functionality of a tunable femtosecond laser source, but it also gives you the flexibility to use all of the new modalities that are being used in nonlinear microscopy. For example, second harmonic generation, two-photon microscopy, Cars microscopy, and stimulated Raman scattering. So all of these techniques become very easy and push button, and so you no longer need 2 or 3 top-notch PhDs to do those kinds of experiments. You now have a system and you can perform all the experiments, and actually without moving parts or needing additional static optics.
Great. Well, thank you very much. It's a very exciting product, and we look forward to seeing it out in the industry at work.
Thank you very much.
Thank you.